So thank you for that gracious introduction. Unfortunately, I will not be talking about the value-free ideal here today because we have to talk about responsible innovation, and that's about as much time as I'll have for. If you'd like to know my thoughts on the value-free ideal, there's a book, there are articles, you can email me, I'd be happy to talk about that. But today we're going to talk about what constitutes responsible innovation from a philosophical perspective. So, and with examples from autonomous vehicles. So in discussing responsible innovation, the difficult thing to think about is that it's not just about having good intentions. Very often, people think, if I have good intentions, if I'm aiming for something good, that suffices to produce responsible innovation. And unfortunately, that is not the case because we are responsible for more than what we intend. We're also responsible for clearly foreseeable outcomes, even ones we don't intend. So, for what does that mean for driverless cars? Certainly, autonomous vehicles, there are lots of great aims built into the pursuit of driverless vehicles. About 2,000 people die every year in vehicular accidents in Canada. A lot of that's due to driver inattention, texting on your phone, being drunk. These are not good things. These are human foibles. We could correct that if we could just take away the human element that is so flawed. We could maybe even get zipper merges to work properly on highways. It'd be nice. So there are really good intentions about pursuing safer and more efficient transport with autonomous vehicles. And I'm sure that we're going to hear more about those intentions from the people who are actually close to doing that. There are going to be tricky bits about how to make autonomous vehicles interact properly with all the non-computerized modes of transportation that are still going to exist, the people who are still driving cars themselves, bicyclists, pedestrians, that sorts of things. But those, again, are things that can be tackled by working on the technological aspects of the system. In addition to making our transportation systems safer and more efficient, though, we also need to think about the overarching regulatory systems that need to be interacted with, and I'm hoping that we hear more on that from our legal expert. So, for example, we're going to need some kind of coordination among autonomous systems. We don't want cars that are heading towards each other to swerve in the same direction towards each other when they're trying to swerve. That would not be a good thing. So we need some kind of coordination. And indeed, it's not clear that we want differential safety systems in different cars on different makers. So for example, imagine you have a Mercedes that is more protective of the occupants of the car than pedestrians, but a Honda that's more protective of the pedestrians than the occupants. That is probably not going to go well with the public if those statistics start coming out. So how do you both protect the intellectual property of your autonomous vehicles while also making sure that they're meeting sort of regulatory standards of safety systems, especially as autonomous vehicles develop using more and more complicated artificial intelligence that is difficult to unpack. And I have a graduate student here who's working on how to unpack artificial intelligence systems, so that's for you, Oliver. All right, so that's all about the intentions, fostering good aims. We need to think both about the particular systems and the regulatory system in which these things are going to be embedded. But for responsible innovation to be fully met, we also have to think about likely impacts that are not intended. And in Canada, there are over 300,000 people who currently make their living driving. So what happens to those people? Are we going to foster social policies that address the coming unemployment that autonomous vehicles are going to create? And this is one of the reasons why a lot of innovators at the forefront of autonomous vehicles are pushing for policies like basic income policies and creating alternative conceptions of meaningful work outside of paid employment so that we can begin to think about how to make our roads safer and more efficient and also not have really difficult impacts of massive unemployment and loss of meaningful work. And then finally, it's not enough just to think about likely impacts and your intentional aims. You also have to think about preventing harmful uses because the world does contain malicious actors in it, as we saw horrifically last week. Some people mean ill. So what you don't want is a system of autonomous vehicles that would work like this, that would be hackable in their underlying inference architecture so that it could be flipped that pedestrians, instead of things to be avoided, are things to be aimed at. and that on a particular day and a particular time, all of the flips occur, and suddenly all the cars on the road are aiming at pedestrians. That would make last week's attack look like a cakewalk. So how do we make sure that the underlying architecture isn't vulnerable to that kind of manipulation by malicious actors? This is the challenge of doing responsible innovation, and why it has to be beyond thinking about just intentions and what you aim for that's good to do responsible innovation properly. Because unless you meet all three of these, when a new technology is released into the broader society, there are massive risks of pushback against the technology or outright rejection, losing the benefits because you haven't adequately dealt with the potential harmful uses or the potential likely side effects. And just to make clear that this actually is the responsibility of scientists, and I'm going to be nice and short, because I was asked to be nice and short, I want to point out that in 2017, the AAAS actually revised its statement on freedom and responsibility to say the following: scientific freedom and scientific responsibility are essential to the advancement of human knowledge for the benefit of all. I think we can agree with that. Scientific freedom is the freedom to engage in scientific inquiry, pursue and apply knowledge, and communicate openly. And I think it's also the freedom to pursue new technologies and new development, because I don't see a big distinction between science and engineering, just so everyone knows. This freedom is inextricably linked to and must be exercised in accordance with scientific responsibility. Scientific responsibility is the duty to conduct and apply science with integrity, which is traditional responsible kind of research stuff, like don't fudge your data. We all know that. In the interest of humanity, this is where it gets tricky, in the spirit of stewardship for the environment and with respect for human rights. That is a tall order, and it is the strongest statement of scientific responsibility as yet been put forth by a major international scientific society. The reason there isn't a Canadian equivalent one is there is no general Canadian scientific society yet. That's one of the things that wasn't formed in the early 20th century when there was an opportunity to do so. So I have to draw on the American Association for the Advancement of Science. Sorry about that. The reason why scientific freedom and responsibility are linked so tightly, and why the challenge of responsible innovation is so great, is if scientists and engineers do not choose to embrace aspects of this responsibility, then someone else does. And that means the scientists would lose their autonomy to make decisions in the practice of their own research. They'd have to have oversight, ethical oversight, over all the decisions made throughout their research practice. So either scientists and engineers embrace responsibility and freedom and autonomy, or they reject responsibility and then they lose some of their autonomy. This doesn't mean that scientists have to do, and engineers have to do this alone. Very often, interdisciplinary collaborations, bringing social scientists in, legal experts in, indeed exemplifying on the nature of this panel today, is a way to help make innovation more responsible. But at the core of it, scientists now have to think about responsibility in these terms. Okay, thanks.
Thank you very much indeed, Heather, for those provocative comments. You set the stage very well. Ladies and gentlemen, I indicated at the outset that Research Talks is sponsored by the President and the Vice President Research of the University of Waterloo. Charmaine, our Vice President Research, is in Ottawa today. But I'm very pleased to note that the President has been able to join us. Ferden came in a few minutes ago and managed to find time in his extraordinarily busy schedule to be with us today. Thank you very much, Ferden. Very pleased to have you here. Next up is Sebastian Fishmeister. Over to you.
All right. Welcome, everybody. I am Sebastian Fishmeister. I'm an associate prof in the Department of Electrical and Computer Engineering, and I will talk a little bit about safety and security for automotive systems. Everybody dreams and has big dreams for autonomous driving. Everybody wants to just sit back, enjoy the drive, let the computer do the hard part of actually driving the vehicle. And not only that, autonomous driving also has lots of promises, whether that's now greener driving, meaning we can save fuel, or whether that's less accidents on the road where we can save a lot of lives that would otherwise be lost because of accidents of being distracted. Well, the computer is never distracted. All this could be done. And in general, everybody wants a stress-free commute where you can just sit back and relax and do whatever you would like to do. But not only that dream, it's also for Ontario, it's very important to know what's going on in automotive because we have a lot of value generated inside Ontario on the topic of automotive systems, whether it's now manufacturing or jobs linked to this particular activity. So let me tell you 3 messages today here about the future of autonomous driving. First of all, is more or less in history, automated driving, which is a precursor of all of this, has been around for a long time. And so, for example, in 1912, you have the electric starter, the first transmission that automatically you no longer have to shift gears. In 1940, cruise control already was around in 1958. ABS was around in 1971, and actually distance warning, a feature that is now being implemented widely and being touted as a new feature, was already available in 1991. Throttle control on your cruise control was already available in 1995, with now Mercedes then optimizing it with an adaptive cruise control. So that's already 18 years ago. Intelligent parking was 2003, and the autopilot, in quotes from Tesla, was in 2015. So automation has already come a long way in automotive systems. The thing that we have to be aware of right now is that, 1, the automation will continue. Number 2, so far everything has been supervised by the driver, and now we're going to try and take the driver out of the loop so that the car is doing everything. And that's where the second message is: autonomous driving is complicated, simply because computers are inherently unintelligent, as you can see in this video here, because they don't know what to do. If you put a car right in front of you and say, drive 200 meters, then it will just continue driving 200 meters until it drives right through you. So computers are inherently unintelligent. And so it's difficult to make them smart and do things. And here's, for example, the architecture developed by a colleague here, Krzysztof Czarnecki, who works also on the topic of autonomous driving. You can see a lot of functional blocks here. And these are all the blocks that you have to build and have to make sure that they are safe and secure. And at the University of Waterloo, we built successfully a demonstrator for Renesas and showed it in the CES 2017 demo, where you can see again here the architecture with a lot of functional blocks. And all these blocks are there to ensure that this vehicle is driving and the machine is a little bit smarter than just a piece of metal that you tell to drive forward or drive left or make a right turn. And it's important to understand that this is tricky and this is time consuming and it's hard to get right. Why is it hard to get right? Because you drive in that weather. And you want your car also to drive in that weather. You can look at this particular picture and make sense out of it. It's actually not a truck coming at you, it's a truck being towed. You can look at that picture and understand that it's not actually a car, a little car that is driving there, that's somebody decorating a bus with a car in the back. You can look at that picture and understand, hopefully, that it's a car painted on this truck and not actually a car. But if the computer looks at this and looks at it and sees where it's located, it might make the wrong decision to think that the car is somewhere else. And extreme cases always exist, like airplanes landing on highways. And we have to make sure that these systems actually all work. And on top of all of this, we're now trying to use computers to learn about what they're doing, and that's tricky. Here you can see something from the CES 2017 demo from a company, which logos I blanked out here. They just made a car drive and learn to drive in a circle. And here you can see one of the emergency stops where the car, during a multi-million-dollar demonstration, did not follow a simple curve. And over the whole week, it actually did this multiple times, as you can see with these tracks here. And that's what all trying the car learning how to take a turn, and it actually didn't appropriately under all circumstances. So the important part for you to understand is in autonomous driving, it's tricky to do this, and it takes a lot of effort to do this, and we have to think about how we can do this. My specific work is on the safety and security side, which is more relevant even than other topics, because if you have now this piece of metal driving around by itself, you have to make sure that you're the one controlling it. As, for example, was broken this morning, there is a known vulnerability in VW and Audi cars. where they can take control over a car. And so what you understand there is, again, these machines that we are building are far beyond what we try to understand. The gentleman from GM can tell you that these systems have 50 to 70 processors, computers, and all of them are working together, and all of them are building something, and it's terribly complicated. Software is increasing drastically. And the problem that we now face is that safety and security together are threatened, that we can actually build these systems in the first place. Because when you look at the increase in vulnerabilities that you can see nowadays, where we had 70,000 vulnerabilities since 2010, about 170 vulnerabilities per day, per week. Just think about what that means for your car that is being developed over 5 years. The cumulative number of exploits that are known on this system are a significant problem. So 71,000 is the number. The challenge is then, of course, the durability, because while you might replace your phone once per year, what do you do with your car? You're not going to replace your car once per year. The challenge is even for industry, how do you even update that car? Does anyone update a 20-year-old car? Does anyone even know the software that's running on a 20-year-old car? And you have to update it weekly because of potentially new exploits. And remember, 175 known exploits per year. And the problem is right now that you can build secure and not safe and not secure systems. As you can see here with the Jeep Cherokee, millions of people are driving this, and it's known to have a vulnerability which has been patched by sending out USB sticks right now. So that is safe and not secure. And here you can see a system that is secure and not safe to show you the difference between that. You can build systems that are mutually exclusive. It's essentially a bubble bath inside a vehicle, and it's secure because you can't really remotely attack the system. It has no connectivity. It's definitely not safe to drive. And so what do I do in my research? Well, in my research, I look into how can we build these systems and make them safe and secure. And the key point there is to have computers watch computers. And that goes into the area of online analysis and online protection, where we then build systems that are analysis changed, where we look into validation data, build models, extract models from system to then provide feedback to designers, and also develop runtime monitors that allow you to alert at runtime whether the system works. For the students in the room here, all of this falls more into the extract, mine, and apply. So you have to look into what data do you extract from systems, what do you mine from these systems on the behavior, and how do you apply this for some benefit for the industry or for just pure insight. And there's a lot of work that I can go through about this. Overall, we try to apply this, whether that's in the aerospace sector, where students are, for example, chasing icebergs with drones, whether it's in the automotive sector, where we build different demonstrators throughout the years, or whether that's just in a lab setting where we, for example, have cooperative driving on there. So let me conclude. Systems are getting too complex for engineering teams to understand. No single engineering team can truly understand what all these systems are doing. We need better mechanisms for doing this, and here at the university we have research teams that work on this. The future, however, is bright, because as these systems produce more data, as become more complex, they produce more data. And it's also bright, the future is also bright for graduates, because systems will never become simpler again. That unfortunately has passed. And there is in the future high demand for people with a background of safety and security. So overall, these are the three messages, and a lot of the work is also sponsored not only by the university, but also by the companies and also by the Canadian taxpayer. So everybody in the room who pays taxes in Canada, thank you very much for also supporting some of this work.
Thank you very much indeed, Sebastian. Your slides are terrific, by the way. But having heard your presentation, I'm not sure I'm quite ready to give up driving my own car just yet. I'm going to wait until you and your colleagues get a little further down the road before I move in that direction, unless our next speaker, Jay, can convince us that the GM autonomous vehicle, is ready to go and has met all of these challenges that Sebastian has told about. Jay, welcome. We're delighted to have you here. The floor is yours.
Okay, thanks everyone. Thanks Heather, and thanks Sebastian for setting the stage. The technology that we are working on, making it clear that it is important, and it is very difficult to make. So almost makes me think about going back and asking for more money. So GM, I think a lot of you would have heard about GM's autonomous vehicle program. And GM's focus is basically the 3 zeros, as our CEO likes to put it. 0 crashes, 0 emissions, and 0 congestion, and this is the new mantra for GM. Heather pointed out that every year, 2,000 people actually, they have fatalities in the in Canada, but that number is quite big if we consider the entire globe. It's about 60,000 every year in US, and close to 1.2 million people in the world every year, they actually die of car crashes. And 95% of the fatalities, close to 95%, are related to human error. This number is even much larger, close to 10 million if you consider people who actually get hurt because of these accidents. So this is something that is very important. Congestion, again, I think my slide doesn't compare with what Sebastian showed, but basically, it's one of the important things. When we talk about efficiency, when we talk about frustration on the roads, and we talk about loss of value in terms of whether it's fuel or time or just the infrastructure cost, it's too much when we consider the traffic on the roads. And, parking spaces, this is just one of the things when we consider about infrastructure. We place so much, we invest so much in basically coming up with parking spaces or the infrastructure, put together the infrastructure to actually drive so many cars on the road. This number can seriously go down if we look at the autonomous vehicle market. So at GM, again, we believe that all AVs must be EVs to support this mantra. We essentially believe that autonomous vehicles combined with the electrical vehicle technology can seriously impact the way we actually look at cars today. So AV will change the world, as we like to call it. Customer experience, how it saves lives, creates time and money. It changes everyday life. And apart from that, it leads to a broader disruption down the line. It'll basically reset the entire physical landscape. It'll reshape what we look at the automotive industry as is today. And at the same time, it generates value. There are a lot of business opportunities around it. There's a multi-trillion-dollar market, as people say, but it's not just about the money, but it's basically adding value to everybody's lives every day. So if you look at the AV sphere, we can basically divide it into the product, which is the autonomous car itself, the network, which is the entire ecosystem around it, and the platform. Today, in the interest of time, I'm only going to be talking about product, and as you can see from some of these incorrect page numbers, this was part of a larger presentation. So just the product, what it is, and what GM is planning to do. So our aim is to come up with the minimum viable product before we put something in the market, and these are essentially the 4 features of what a minimum viable product should be. It has to be autonomous. It should be deployed. It should be deployable at a large scale, because if you're thinking of autonomous vehicle technology and you're thinking about putting a handful of vehicles on the road, it's very difficult to add value. Maybe you have a proof of concept for the technology, but if your solution is not scalable, it's not going to help the people that you're trying to help. So it has to be scalable. It has to be safe. And when we are talking about safety, it has to be safe for people inside as well as outside on the roads, and for everything around the vehicle, whether it's the roads or just the property. The vehicle has to be safe, and that is actually one of the most important factors, and probably, as Sebastian pointed out, the most difficult thing to achieve. And it has to be intelligent in one way. It has to be able to manage the complex environment. So if you have an autonomous vehicle which can probably work in some of the environments that you usually encounter, well, you might start using them for that kind of that particular kind of usage, but ultimately, if it's not intelligent enough to be deployed in a larger, complex environment, you're not going to see the value out of it. So when we talk about complexity and the economic opportunity, this is basically what the curves looks like. You know, initially it's easier to come up with a solution. The complexity is less, but as you move forward and forward, the complexity of the environment is exponential and becomes very, very difficult. GM is one of the, let's say, as the slide says, GM is the only company which is developing a fully integrated solution for this approach. And the reason is GM is kind of in a unique space, or let's say, it has, it's basically GM has, has a century of experience developing cars. It has the knowledge of, how cars should be developed to the highest standards of safety. At the same time, the GM acquisition of Cruise Technologies, basically GM has the capability to develop autonomous vehicles, which is basically the brain of the vehicle. So combined with GM's core knowledge of developing cars and the ability to develop the intelligence in the vehicle, GM is uniquely positioned to actually develop these vehicles from scratch. As you can say, none of the other competitors are today in that space. So we are one of the first companies to actually start building autonomous vehicles in a plant on an assembly line at large scale. When we talk about the product, the minimum viable product, there are some guidelines, or there are some goals that we have set in mind. When we are talking about the capability, we consider human capability, evolved over hundreds of years. It's pretty much consistent and pretty much stable in terms of driving cars. We want to have a minimum viable product which is more capable than humans at least, and that is something that we want to start with. Over the time, the capability will increase, but the minimum viable product should have a minimum capability which is higher than humans. The cost, well, for a scalable product, you need to manage the finances in a better way. Initially, the cost of an autonomous vehicle will be higher than a human, but the aim is to reduce this cost drastically as the time progresses. User experience, again, an AV will probably not match a human in terms of user experience initially. If you take an Uber and discuss the last night Blue Jays games with your driver, well, the AV is going to fall short of that. But the aim is to make it much better over the years. And domain capability. When we talk about autonomous vehicles, usually people question about, okay, these vehicles are going to become ubiquitous. Then how are you going to handle rural areas? How are you going to handle inclement weather? And all those questions are valid because the domain capability of these vehicles will be less as compared to what humans can do today, but that is going to change over time. So GM is basically, we have a unique approach. We have set a level of a minimum viable product, which basically we want to launch in the market. The focus is on safety. First of all, the vehicle has to be safe. There's no doubt about that. And it has to be deployed at a larger scale. So we believe firmly GM is in the lead for obtaining that. And you would have seen a lot of recent announcements about people shelving their autonomous vehicle program, whereas GM steadfastly said that we are basically planning to launch our autonomous vehicle fleet in 2019, and that's our goal. Thank you.
We now move to another dimension of this topic, the dimension, may I call it the legal dimension, George? Would that be appropriate? Anyway, George, thank you for being here. We're delighted that you're able to contribute to this discussion, and the podium is yours.
And the legal dimension that I'm going to weave into this discussion, it's very interesting. I'm going to talk about how the law is sensitive to Heather's objectives and moral and ethical aspirations, working, though, in the crazy environment that Sebastian pointed out, I've never seen the one with the bubbles in the car, and I wasn't exactly sure what that was trying to show, but it just said, yeah, there's a lot of craziness going on. And then the third plane, or the third axis, is Jay's point that, frankly, you do have to make money at this. So the law tries to accommodate that, and what makes it very complicated is traditionally automobiles, trucks have been mechanical, physical devices. They're now becoming, frankly, computers on wheels, and perhaps the most complex IoT platform that's out there. And they're dangerous. I mean, when your normal laptop, computer, or PC goes down, it's an annoyance. If you miss a term paper deadline, it's maybe more than an annoyance. But when it's a car hurtling down the 401 at 140 clicks, and then you've got a glitch, now we have a much bigger problem. The other complexity, and again, the previous speakers alluded to it, the supply chains, the technology ecosystems, and so on are incredibly complex now, because it's not just traditional OEMs like GM. It's a whole range of other players. When you open your phone and you see all the tiles, every one of those is a disrupted business. And again, in our normal safe environment, as it were, that's an interesting observation. When you're hurtling down the 401 at 140 clicks and you're thinking about all the disruption, do I want that much disruption in my physical safety context? Jay alluded to this. The lawyer in me saw the little fine print. He said minimum viable vehicle at level 4. This is, and Heather alluded to this as well, these are the so-called degrees of autonomous vehicular, sort of self-driving that are out there. 0 is still your dream and mine to keep driving because I feel safe behind the wheel. 5 is it's fully autonomous. And again, Heather alluded to this. I actually think legally this is going to be a very relatively safe environment when we're all there. And the Hondas and the Toyotas and the GMs are all coordinated and they're all working together and they all understand presumably a common standard, and they all know I swerve right if I'm in the right-hand lane and I swerve left if I, et cetera. I think, though, the next 10 to 15 years, when we're in 1 to 4 territory, this is where the legal stakes get very high. The personal safety issues are very compelling because a buddy of mine just took delivery of an Audi that has elements of 2 and 3. And he's a busy professional, and he said, look, just drop the car off. And the dealer said, no, I actually have to spend an hour with you to go through a checklist, and you sign at the bottom that you've been suitably trained. And I'll get to this in a moment. There's a legal rationale for that 1 hour. But what happens when the spouse drives that Audi, or the kids, or a friend who don't get that 1 hour of training? Now we're into the complexity of the 1 to 4. So basically, the legal system approaches responsibility for technology traditionally from, and largely from, what we call the negligence standard. And negligence law is an entire course in law school. I'm going to give it full justice, though, in 3 minutes. All you need to know about negligence, and I'm going to do it with a formula, because I said I'm at Waterloo, math is the strong suit, so that's the next slide. But basically, you can be negligent in designing the vehicle. This is presumably where Sebastian plays a lot, but also negligence in production, particularly as you get the software stack interacting with the hardware, the infrastructure components. Negligence in operation, this is very interesting because the statistic that Jay put up, today 94% of auto accidents are human driver related. those numbers will drop dramatically, but every accident will now become a product liability claim, typically related to the technology. So those of you in the room that end up working with Jay on these systems, your sphincter muscle should be twitching at this point, because right now, those cars you work on, you're not going to be implicated in any of that litigation. In the future, you will be hauled out of your lab or your cubicle, and you'll be a witness, and I'll show you what they're going to be grilling you on in a minute. Negligence in training, that was my point about, you know, the 1 hour of training for how to deal with semi-autonomous vehicles. There's also a very rich jurisprudence on negligence for failure to warn. Product recalls that you probably read about in the press and on media and social media and so on. If you know that your product now has a dangerous element or a defect, you can't just sit back. You have to go out and speak to the public and the owners and so on and so forth. And in the, you know, autonomous vehicle space, what does that mean? What is your obligation to tell people, hey, by the way, you need a software patch immediately, because otherwise, I like the 2 slides from the test track that not only did you see the car go off, but the tire track showed that this was happening fairly frequently. And then there's a fascinating line of jurisprudence going way back over 150 years. You can actually be negligent if you don't adopt new technology. A seatbelt would be a classic low-tech example. And I'll talk about that. And the good news, and this is why everybody should just exhale for a moment, negligence law doesn't require perfection. And this is why Jay can sleep at night on that minimum viable production vehicle. We're not looking for perfection. Even today, over 1.2 million people die annually, globally, because of car accidents. We could, in theory, bring that number down even for non-autonomous driving, but we don't because the benefits outweigh those restrictions. But we do expect a so-called reasonable standard of care. So how do you operationalize this? Here's the formula. And there is actually a line of analysis. I'm a U of T law grad, and we did a lot of law and economics, and this is the forte for that discipline. Basically, negligence is a function of the probability that a particular harm will occur, and then you also measure the cost to avoid that particular harm. So the seatbelt example is a perfect one. It's a relatively inexpensive device, but it not only saves lives, it saves injuries. In a perverse way, someone who is seriously injured in a car accident often economically costs society more than the death. I know that sounds perverse, but this is what litigation, I'm not a litigation lawyer, but this is what litigation lawyers talk and argue about. So it would be today clear negligence for an OEM not to have a seatbelt as standard, operating equipment, because the probability of the event that you will be thrown from the car if there's a head-on collision and so on is very high, and the cost to avoid is very low. Now, what becomes very interesting in Sebastian's world is as you move into autonomous vehicles, where do you draw the line on both the probabilities of the harm occurring and what is the cost? I remember years ago talking to the fellow in Washington that approved medical devices for the market, and he said, we're being approached by software-based devices, pacemakers, that we know are going to fail because software cannot be made perfect. And so when you run the formula with that kind of probability, and Carnegie Mellon tried years ago the ADA project, to make software perfect, and someone in the room is going to ask a question or make a comment, say, no, George, you're wrong, you're so out of date. Waterloo now has software that is perfect. That would be music to my ears, but my current understanding is it's still not quite there. And so that's what makes operationalizing this formula very, very difficult. And then just really to add a few more glosses onto it, I actually think where we need to spend more time is in the semi-autonomous safety space. Yes, we've had cruise control for decades. The first time, I have a couple of car clients, and the first time they took me out for a test drive with dynamic cruise control. How many of you have been in a vehicle with dynamic cruise control? A few of you? It scares the, oh, this is being taped. It's very scary. And so we're on the 407, and he says, oh, well, let me show you how it works. And he's very proud, da, 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 da. And then it sort of actually doesn't work at some point. We're about to go, because what he didn't have was the other feature that does the automatic stop. And he was in the driver's seat, thankfully, and so on and so forth. And he says, yeah, well, we're still working on it, and so on. And I vowed, never again to be in an alpha or beta test. I want the commercial release only. But it's level 1 to 4 or 2 to 4 that I think are the particularly challenging ones. And I'm hoping that a lot of UW students put a lot of their brain power into that. I think I've talked about this. Oh, what's also fascinating is, and Heather will mull over this, and maybe your grad student as well. There's a jurisprudence in the US in particular. Remember, some of you perhaps who are older will remember, there was a long line of litigation over the placement of the gasoline tank. And it was shown that when the gasoline tank is positioned at the rear of the vehicle, when there were rear-end collisions, they exploded, and the deaths ensued and so on. So a number of the OEMs initially moved the gas tank from the rear to the side. And sure enough, the number of rear-end collision fatalities dropped dramatically. And lives were being saved, all over the US and eventually all over the world. But then there were a new line of cases involving the side collision. And I don't know which OEM it was, but their first argument in defense in that case was, well, yeah, Your Honor, it's still not perfect, but look at all the lives we've saved by moving it to the side. And the judge said, hey, that was last year's, issue. I'm just looking at the side collision. So you actually don't get credit from a societal kind of broad human welfare perspective, which is really kind of sad, because you should, I think. But, and we'll talk about regulation in 1 minute just to finish it up. Oh, and then if you think about some of these systems and some of the complexities around that ecosystem that I mentioned. So when it doesn't work, is it the OEM supplier? Is it the AI expert software developer who created the shell? Is it the GPS supplier, the LiDAR? Now, when I teach a course up at Osgood on this sort of stuff, I actually have this on the exam, who's responsible? And the real answer, of course, is, well, they're all going to be joined in the litigation, and they'll all have some degree of responsibility. And that's another aspect that makes this so complicated, is the handoffs between one component and another, and the way that the data is going to flow and so forth, again, just add to the complexity. But we've worked through this before in other environments, so it's not completely, up for grabs. Just a couple of words. If you're a startup at UW and you're working in this space and you're saying, oh my gosh, maybe I should go into another field because the liability here looks a little bit daunting. The good news is, contractually, if you're working in that supply chain, you can actually limit your liability contractually. So if you sell to GM, you can actually shift the risk to GM and let them take the bulk of the responsibility. The other market that has kicked in is insurance. And insurance is really, really important in high-risk environments like the car industry. What's fascinating in the insurance space, just as a quick aside, and I don't know how many of you are already taking advantage of this, some of the telematics aspects for insurance where you can actually price insurance by the driver and their behavior because you're now tracking it, you can produce a much better sort of pricing down the demand curve for insurance. And that is going to change dramatically the insurance market, as will the AV market, because again, the 94% of those accidents, those are going to drop dramatically. So there'll be more insurance, frankly, to cover the risks from the product liability side. And then finally, how the public policy typically works is you get 5 or 10 years of litigation, specific cases, negligence decisions, and then the legislature comes in and then brings in a regulation. So for instance, for level 5 interoperability of all these systems, presumably the legislature will step in and say, look, here's a standard that everybody has to plug into for the interoperability on the safety systems and so on. And what I'm hoping is that we'll be a little bit faster off the mark on the regulatory side and not leave it with the lag that you often get. Just one other word, if liability wasn't enough, as a UW grad working in this space, you also have to think of privacy. It's very, very interesting. The Privacy Commissioner has already said that geolocation can be a type of information that's covered by privacy law. Usually privacy law only covers personal information, your core biographic data. But if you're visiting a certain hotel every Wednesday at 2 in the afternoon, and your spouse doesn't know about that, but your car is tracking that, that information can become very personally engaging. So there is a recognition that these systems that are now so data infused can present us with personal privacy issues. And so again, when you're designing these systems, in addition to the liability issues, you have to be on top of the privacy stuff. And then Sebastian already worked us through security. So enough legal food for thought for the moment.
George. Fascinating insights. Thank you very much. I've always realized life was complex, but after listening to you, I've come to realize it's about to get a lot more complex and a lot more complicated. We now move to discussion mode, and I would like to invite our panelists to move to the chairs at the front of the room. And the way in which this is going to work is that you folks in the audience are now invited, or will be invited, to pose questions or comments to the panelists. And you could do it to a single panelist, or you could do it to 2 panelists, or you could do it to all of the panelists. So the floor is now really yours. But there's one nuance that I need to advise you of before we proceed, and that is that this event is being recorded, both visually and audio recorded. And in order to feature in the recording, you have to use a microphone. So that does make it a bit complicated. And I believe Kayla is going to be the person who moves the microphone around from person to person. And so if you have a question or wish to make a comment, please raise your hand and we will bring a microphone to you. And you folks have 2 microphones, so you're in good shape. You can share them. So on that note, let me open up for discussion. Yes, Vic.
Hi. I'd welcome any of you to answer this, but I'm intrigued by how excited we seem to be about having self-driving autonomous cars when so much of the same technology could make cars completely crash-proof and still leave us in control of the supervision of the complex situations that are almost impossible for a computer to determine what's going on. You know, we could actually keep the cars from being able to hit each other, but still kind of be in control of these more complex things that will maybe not be recognized by computers. So why are we working on this convenience instead of the safety?
That's a good question. Who would like to take that on?
All right, so let me take a first
You sound a bit
stab at
reluctant,
it.
Sebastian.
Sure, I'm always intrigued. So some of the technology that you saw from the slides on automated driving already feature technology which you would need in an autonomous vehicle. And so the way that I currently see the trend is that, well, researchers and industry are developing more and more features that you would need in a fully autonomous vehicle. But until we get there, they have byproducts that fall under automated driving, which already make it into existing products. Like, for example, GM Super Cruise feature, and other companies have a similar feature. That already helps you that you can drive on a highway and the car takes care of you staying on the lane, not hitting a vehicle in front of you, and basically you can relax while you use these particular features. And it's still not level 5 fully autonomous driving. So in short, the research and the development in the direction of autonomous vehicles helps us to develop technology which can go into vehicles earlier before we have fully autonomous vehicles. And that's how I currently see that the industry pursues the technology and pursues the commercialization of this.
Would the other panelists like to comment?
Yeah, I can add something to that. So the way I understand is that, you are, if I understand the question correctly, is, why are we actually planning to remove humans from the equation, right? Is that what your question is? So,
Sounds terrible.
well, so, my answer to that would be actually, we are not. So when we talk about, autonomous cars, we are trying to bring all the technologies in the vehicle that would make it more and more safe. Although, in our experience, in everybody's experience, right, human beings make mistakes. So as long as you allow a human being to retain some control over the vehicle, there is a possibility that a mistake might happen. And as this technology improves, these are the mistakes that we are trying to, avoid. This is the target that human beings should, even if they are capable of making some mistakes, they should, the car should take over. The car should be able to avoid those kind of incidents. If you look at some of the accidents today, right, it's, negligence or maybe, not paying attention is one of the reasons, but other things also go wrong, right? Sudden scenarios where a human being is not capable to kind of take a decision on how to avoid that accident. Autonomous vehicles will be able to do that because they see more, they can perform better, they can think faster, they can think better in a lot of ways. So if you look at an autonomous vehicle today, it has sensors all over the place. It's not just looking in the front, which what human beings usually do, but it's looking at all sides. It can see 5 cars ahead of you. It can see cross intersections. It is connected to the internet. It knows where the traffic is. It knows who's approaching at what time, at what speed, right? It knows a lot more than normal human beings do when they're driving the vehicle. And it has a lot more better decision-making capabilities, at least for the things that it has been taught to do. So the aim is to, eventually make human lives better by just saying that, okay, there is a machine which can perform some functions better than what you can, and you might just as well sit back and relax and possibly do something
Heather,
else.
would you like to comment on the notion of taking humans out of the equation?
Yeah, I don't think Jay really means to take humans entirely out of the equation. But I think you make an excellent point. I think there's nothing inevitable about moving to stage 5, autonomous vehicles, and we might decide to pull back from that in practice. So we never, for example, we don't use Concords to fly across the ocean anymore. There was a better technology. It moved us faster between, Toronto and Paris, but it turned out not to be economically feasible, and it turned out to have 2 substantial environmental risks. So there's nothing that says that in 50 years we will all give up our driver's licenses. It might happen, and it's well to think through the kinds of implications and the kinds of regulatory frameworks, the kinds of legal issues, and the kinds of technological challenges that we might confront. And it might be the case that it's just not worth it in the end, that the vulnerabilities or the problems are too much. Or it might be that once you get the cars with all these safety features so well ensconced with, say, level 3 capacities, that human error fatalities drop so much that the autonomous vehicles can't do better. Or it might be the kinds of errors that autonomous vehicles make are so uncanny to us that we can't adapt to them. Right? So this is all sort of open territory. And I don't think we should think that there is this particular path, although I admire what GM is trying to do.
But actually, just one other observation, because your lead-in phrase was, well, we could make them perfectly safe today. And in a sense, you're right. So I actually sit with car companies today, and we look at the user experience, the driver experience, and we say, well, what could make it safer, but without, in a Kantian philosophical sense of we're all moral autonomous actors, you could disable a mobile phone when it hits a certain, degree of speed and so on and so forth. And my phone says, sorry, it appears you're driving, but you can click to say, no, I'm not driving, I'm sitting in the passenger seat. And how many of us have clicked when we weren't in the passenger seat? So you can override that. Remember photo radar years ago? We could absolutely keep all the speed limits, fully enforced, but people are unwilling to give up this moral autonomous notion that, why do we have cars that can go 200 clicks when the speed limit's 100? So it's always a balance, and as I said on one of the slides, perfection is not the objective. We're willing to put up with a certain amount of, defensible chaos for freedom and for the other values that we put up against that.
Thank you, George. Sebastian, one short comment, and then we're going to move back to the audience.
All right, so as a short answer, and it's always good to have controversy on the panel, I'm absolutely in favor of taking people out of the loop, simply for the following reason. The vision is much larger. We only talk about like 4 wheels driving on a highway, but actually, think about it. You can use these vehicles to deliver pizza. You can use these systems to go into a mine shaft and actually where it's really dangerous to get stuff. You can have these vehicles operate automatically in disaster zones where you couldn't have people go. You have these people or these vehicles possibly in space exploring where no human can go. So the vision is much broader than actually right now, well, okay, so we have people in a car and I like driving and that's why we shouldn't pursue this type of technology. So I think the vision is much larger, and I'm absolutely in favor of developing this technology so that we can take people out of the loop.
All right, now back to the audience. Who would like to address a question or a comment to the panel? You got somebody over there?
So Sebastian had all these examples in his slides of when humans are better than the cars, and Jay was talking about how cars can be better than the humans. How do we decide in a situation that the car is going to ignore what the human says versus do what the human says because the human's interpreting something that's strange, like the car painted on the back of a truck?
Panelists?
So yeah, I fully agree with the examples that were presented, and what I'd like to think is that these are all different scenarios. Like for example, the car that was painted on the back of the truck, or the car that was jutting out of the bus, right? The design. So these are errors that a computer can make, and there are ways to actually mitigate these. If you look at autonomous vehicle, they don't just rely on vision. So if you had a simple camera, you might be able to make that mistake, or a computer might be able to make that mistake. But then you use other sensor modalities as well. You use LiDARs, you use radars, you use short range, long range, different kind of sensors, so that you actually you cross-verify that what you are seeing or what one sensor is seeing is correct. And this is very akin to how human beings actually function, right? If we see something, but we don't completely rely on what we see. We also rely on other senses. We also rely on what we hear. We rely on our instincts. These are all the different sensors that we rely on when we want to make a decision. And the cars are similar in that nature. So when we talk about limitations, there are always ways to mitigate those limitations. I agree that there will be scenarios in which you might feel that a human being might take a better action, right? And that is why when we talk about these technologies, they sort of come around slowly. We are not looking at a future where we suddenly say that we want to remove all the cars, put all autonomous vehicles on the road immediately for all kind of purposes. People say about autonomous vehicles, that they're disrupting the market. Frankly, I think that AVs are nothing close to disruption. It's a completely evolutionary technology. Like in some of the presentations that we saw, right? Some of these technologies have been around for 20, 25 years now. And they are evolving from that level to the level that we would probably see in the coming decade. So it's slowly moving towards that. It's slowly getting better and better. And we will see these kind of technologies deployed in the scenarios that we feel they will be able to make better decisions in. Human beings will still continue to, if you want to drive in the middle of Wisconsin, if you want to drive your truck all the way, up the Andes or Himalayas, I probably won't see autonomous vehicles over there for a long time. So there will be scenarios and environments where autonomous vehicles will not function as good as humans.
Okay, thank you. Good response. Other questions, other comments?
But just one quick thought. With respect, I think on your slide, just to be controversial for a minute, when you say 0 accidents, I think that is actually not the kind of expectation that we should be setting with consumers of future automobiles. The first fatality that we've had with a semi-autonomous vehicle was in a fairly, normal kind of setting, but the LiDAR couldn't detect the side of a truck, couldn't differentiate the side of a truck because it was light-colored with the sky. And, it's an open question. Was that a, quote, mistake in the programming? Was the, data set insufficient to teach it about that kind of... My argument would be, look, there will be, quote, mistakes or deficiencies or design deficiencies in these new systems, but don't compare that to nirvana. Compare it to 1.2 million deaths today from human error, because humans make way more mistakes differentiating their environment. So if we can bring it down by a factor of 60, 70%, let's not set the expectation of 100%, because there will be problems with the new technology. But the dream is that overall, it'll still be way better than humans.
Thank you. Ferden?
Thank you. Fascinating presentations. Thank you so much. And John, this was brilliant to put a panel in front of the audience. Many questions, but I'll make it short. In predicting the future, are you making several assumptions, one of which is the public/mass transportation will remain the same. So therefore, GM and other companies, they will base this on selling cars, as opposed to there will be less reliance on individual vehicles that people want to go from point A to B. That's number one. Second, are you envisaging our 401, for example, that will only have autonomous vehicles, so that John won't be able to drive his 1957 Aston Martin on 401?
And you, sir? What won't you be driving?
Mine is my 58.
Just, do you see a hybrid mode on our highways, or will there be only one type of vehicle that's autonomous? I'm just terrified to think that you have 10 autonomous vehicles and then I'm driving my own and I make one mistake and computer will have no idea, cannot predict my behavior because it's unpredictable.
Panel.
Sorry.
So there may come a time when someone like you thinks it's just too risky to drive my own car on the 401 because the majority of the cars are autonomous and fully autonomous and the driver is checked out or is riding comfortably while watching Netflix. So, you know, at that point in time, it might become your sort of personal decision to no longer drive a vehicle. It might also be, I can imagine a scenario where it becomes really hard to get a personal driver's license because it's no longer seen as a necessity because you can always just Uber up an autonomous vehicle. And you don't even own, like everyone's driveways become gardens because no one actually owns vehicles anymore, right? And, you know, it's just garages become storage spaces. That is one particular sort of scenario. I don't think we can decide at this point in time which scenario is in front of us and how far down this road we're going to go. I don't think we're going to become a country of pure mass transit. Waterloo isn't dense enough. And a lot of the neighborhoods are never going to be dense enough to have sort of effective streetcars. The neighborhood I live in is not dense enough. So it's always going to be individual vehicle run. Unless, you know, we sort of have a catastrophe and Waterloo gets blown up and we have to rebuild it. And we decide to rebuild it around an ion core. I don't think that's a nice scenario. I don't want to think about that. But when you're doing this kind of planning and you want to be responsible, what you do is try to foresee a couple different scenarios and then try to think about the implications and try to maximize the good and minimize the bad.
Okay, thank you. Would other panelists like to
So,
comment?
just quickly, one of the projects I'm working on in Toronto is I'm helping Waterfront Toronto with their Sidewalk Labs Google Alphabet project for the waterfront. And there are musings about, on, you know, hundreds of acres, not allowing private vehicles. So your 58 or 57 Chevy won't be allowed, and there'll be sensors lining all the streets, and it'll be fully AV, and transportation as a concept will change. But what about on the 401? We have the AV lane where you can platoon, and then those who want the personal driving experience, they'll be in another lane. It'll probably be on the right-hand side. It'll go slowly. You'll kind of wave to people as you go by. So, I think there'll be fascinating societal implications for how we kind of work through that. But don't you really want to read on that drive to the airport? And no. I get a car soon. There'll be an app for that.
So just to answer your first question, right? Like, you know, we've talked about what a utopic future may look like. You know, where we can drive efficiency in terms of whether it's the public infrastructure or your public transit system, how they are going to improve or they're going to change or they may go away, things like that, right? It's very difficult to predict all of those things today. Having a solution where you say that I want to remove all the cars and just put autonomous vehicles on the road, it's actually easy technically, right? It reduces the complexity for developing an autonomous vehicle because now you are taking away a lot of unpredictability. But that's not the aim here, to be honest, because then you are actually asking for a very large change for which probably you're not prepared for. So when we are talking about today's autonomous vehicle roadmaps in general, right, every organization probably is putting autonomous vehicles side by side cars that will be driven by humans. That does increase the complexity, yes, but then it is again an evolution. So you will be able to keep driving your vehicles for a long time to come, in my understanding, 20, 25 years, probably more than that. And you will see autonomous vehicles ride alongside you. It's just like how rideshare evolved, right? People used to ride their own cars, but now, people are giving away their second vehicles because they prefer riding in Ubers or Lyfts or, just taking it to airports. Airport parking lots are getting redundant slowly. The occupancy is falling every month. So and now it's just second nature. If you want to go to an airport, you don't even think about taking your car and parking it at the airport. You just say, okay, I'll just take an Uber. It becomes second nature slowly. It might, it might go that way. It might not. It's very difficult to predict. But one truth is that, this is going to slowly creep in all our lives, and everybody's going to get different kind of experiences from there. How soon do we get used to it it depends on everybody's personal nature.
Ladies and gentlemen, unfortunately, I was going to say we're out of time. Is it quick, sir? Okay, one more question, and if the panelists could be quick in responding, I'd be grateful.
Thank you. Hi. I just wondered if, and thank you for the nice presentation. And I just wanted to ask you, I installed several different sensors at the University of Waterloo sites, at Highway 41 and Landfill, Waterloo. And during last 7 years, I found out the traffic characteristics of the vehicle at Highway 41 specifically is not that safe that we think. Specifically at the truck lane, and my sensors recorded speeds more than 135, close to 160. At least for 3 days of collecting data, I have 5 to 6 vehicles between 150 kilometer per hour to 160. And in that lane, that the trucks had speed limiters, and they can't go beyond 110. This would be a concern of safety. And at the time of data collection was not, in the midsummer with the crazy young drivers at the truck lane. It was in March, and it was specifically at the freeze-thaw cycle in Canada, in South Ontario. And I just wondered, to quick ask, if you are interested, like GM or any part of the party is interested in, first of all, sustainable safety in transportation before application of autonomous vehicle. And the application and implementation of sustainable safety is not a very hard thing. And the other things is freeze-thaw cycles and effects of that on AVs. That's it. This is my question.
Thank you. In the interest of time, I'm going to invite one panelist to respond to this. And I was actually thinking it should either be Jay or George. George, this sounds very legal to me.
Well, the one point I will comment on is the freeze-thaw issue. When I see, again, in the news, another successful test of an AV car in Nevada or Arizona where it's sunny and it never rains and snow is like completely foreign as a concept. I live in Ontario. I want to see it tested in Aurelia, in snow, and you had a great slide. We've all driven that, right, when that snow is beaming at you. I think that will be an environment that we need to, solve for, and we'll convince. And you're so modest. There's like 800 of you now in Oshawa and Markham, and I'm sure you're going to be bringing a Canadian perspective to the testing, because that is so important that we not just have, Arizona tested cars, but we have crazy Ontario weather cars tested, right?
And on that note, thank you very much. Crazy Ontario weather, we all know what that's about. I'd like to bring this event to a close. First, let me once again thank the panelists for their contributions to this event. Thank you very much indeed. And I'd also like to thank members of the audience for your participation and for coming. We really appreciate it. The next research talk will be in early September. We'll keep you posted, and we look forward to seeing you again then. Take care.